Hi, Assalamualaikum. Welcome back to this inequalities. So before this we have seen the linear inequalities, but today we're going to focus on the quadratic inequalities, and also the inequalities will involve the fraction. Alright, now suppose we have these quadratic inequalities, so we have to write the in general form. Like usually we'll bring that 5 to the left side, like we have x minus 1 minus 5, which is greater than 0, and then we simplify this one. We'll have something like minus x minus 6, which is greater than 0, and then we can actually find and factorize this part. All right, so we'll have something like x minus 3 x plus 2, all right, which is greater than 0. Okay, so we know that the critical points are positive 3 and also negative 2. So how do I know that what do we call the these critical values are positive 3 and also negative 2? So we just need to write this. All right, minus 3 x plus 2, which is equal to 0. So we have x equal to 3, also negative 2. So when we have these what we call critical values, so we have the negative 2, you put on the number line negative 2 and 3. So meaning to say that now you have 3 regions to be considered, which is the first one is here, the second one is here, and the third one is here. So you have 3 intervals now. So you write the interval first. All right, you have to build this table. You firstly write the interval for the first part, which is from negative infinity until negative 2. For the second one, which is from negative 2 until 3, so we have something here, and the last part, which is from 3 until infinity. So you fill out with this table, and now we are going to fill up the part where we have the factors. So the first one is the factor x minus 3, and the second one, which is the x plus 2. All right, and the last part, which is to find the multiplication between x minus 3 and x plus 2. Why? You see here that we multiply x plus 2 and also x minus 3. All right, now we have this. All right, you have to take a test value inside these. Right, pick a test value, any values as long as it's in this interval. All right, the first one, suppose you have negative 3. All right, don't take negative 2 because negative 2 is the borderline. All right, because if you take the negative 2, it will become to 0. And then we have the one here, which is 0. Any values as long as it's easy for you to substitute. And the last one will be maybe 4. All right, you can pick any values, 4, 5, 6, and so on. All right. Now we are going to substitute this test value inside this x, all right, and also this x. So what we will have, right, for example, first one, if we substitute negative 3, if we substitute a negative 3 here, and then we will have a negative number. If we substitute with 0 here, and then we'll have negative, and if you substitute with 4, and then we get positive. Right, you just substitute with the test value here. Now the second function, if you substitute with the negative 3 inside here, you'll get a negative number. If you substitute with 0, you get positive, and the last one, if you substitute with 4, you get positive. Now you find the multiplication between these two. All right, so to get this, so negative multiply with negative, so you will get a positive number. All right, negative with positive will get a negative, and positive with positive you get a positive. All right, now we want to get the part where it is actually greater than 0. So greater than 0 means it's positive. So this part, all right, means it's here and also here. Okay, so the intervals is this one and also this one. Right, so we are going to write the final answer for this one. Right, suppose we have this one as, all right, okay, so the final answer, all right, suppose we want to write the final answer as the what do we call, interval form. All right, so it will be from negative infinity union with negative infinity up to negative 2 union with 3 until infinity. All right, negative infinity up to negative 2 union with 3 until infinity. All right, I hope you get the idea how to get it. All right, so because it's positive, why we take the positive parts only? Because it's greater than 0, so it should be a positive number. Right now we have this one as the final answer. Should we include -2, the border point here, the border line here, -2 and also 3? No. Why? Because it's greater than 0. If it is equal to 0, then we can take -2 and also 3. So that's why we have the normal bracket here, not the square bracket. Okay. And then if you want to write your answer in what do we call number line, all right, so you have -2, 3, so you have something like this. Okay. Okay. All right, you have something like this. So this is the final answer for this one. Okay. Okay. Now, okay, if you want to write in inequality form, and there, so you have something like x is less than -2 union with x which is greater than 3. All right, so we are done with this one. All right, let's go to the second part. The second one here is the fraction, which involve the fraction. All right, so now we the functions have been factorized, so we can't factorize anymore. All right, so we just need to substitute inside these. All right, so what are the critical values? To consider the critical values, you have to take x plus 3 which is equal to 0, x minus 1 which is equal to 0. So you have the critical values are -3 and also x equal to 1. So these are the critical values. So you know that your number line will be -3 and 1. So you have 3 regions: the first one, the second one, and the third one. So consider the first region, which is from -infinity until -3, the second one which is from -3 until 1, and the last one which is from 1 until infinity. All right, now you want to what do we call, fill up with the factor. All right, so x plus 3 and also x minus 1, and the final part here is actually x plus 3 divided by x minus 1. All right, now you have to take a test value. Pick any value that you like within this interval. All right, so is 0 in this interval? No, it's less than -3. It should be -4. All right, so 0 is here, and you can take 2 here. All right, you can take any values actually, -2, -1. All right, 0.5, up to you, as long as easy for you to substitute. Now we are going to substitute this test value inside these functions, and also this one. Right, when you substitute with -4, you will have a negative number, and this one will be a negative number. If you substitute with a 0, you get here is positive, because 0 plus 3 will be 3, which is positive number, and 0 minus 1 will be -1, so negative number. If you substitute with 2, and then you will have a positive number here, and also this one will be 2 minus 1 will be +1, so positive. And if we divide these two, all right, so you divide this what do we call symbol here, negative, we divide it with negative, we get a positive number. This one we get a negative number, and this one we get a positive number. But okay, and now we are done with the table. We are going to write the answer. Now we want to have the inequalities as that it is less than or equal to 0, meaning to say that it should be a negative. Right, so this one should be is the answer. This is the interval where it is actually the negative. The inequality will be a negative. But all right, we are going to write the final answer. All right, this part you have to be very careful. All right, so firstly we know that it is in the interval -3, 1. But the question is -3 and also 1 included? Right, so let's see. We want to have it less than or equal to 0, meaning to say that we can have it equal to 0. So the first one is -3 included? Yes. So we have a square bracket here. Why -3 included? Because when you substitute -3 inside these functions, all right, so you have a -3 plus 3, we have 0 divided by -3, a -4, so 0 equal to 0. So it can be equal to 0. Now we have equal to 0. Just now we don't have the equality here. All right, so now we have the equality, therefore it's included. But can 1 be included to get it equal to 0? What if you substitute 1 here? You'll be x plus 3 divided by 0. All right, anything divided by 0 is undefined, therefore we cannot have 1 in the interval, therefore 1 is not included. That's why we have something like this. All right, so this is the interval form. If you want to write the what do we call the inequality, the what do we call the real number line, so something like this. So -3 is included, 1 is not included, therefore you have a line here. Okay, something like this. If you want to have a inequality form, all right, so you have something like which is less than, greater than, equal to -3 but less than 1, right? So we have 3 forms of answer. Depends on the question, ask you to write the answer in what form. All right, let's go to the next one. Suppose we have this type of inequalities. So what we have to do is to expand this one. All right, so we have something like 2x squared plus x, and then we'll bring 4x and also positive 2 to the left side, so something like minus 4x minus 2, which is less than equal to 0. We simplify this one, we'll have something like 2x squared minus 3x minus 2, which is less than equal to 0. And then we have to actually factorize this one. All right, you have to factorize, you have to know how to factorize this one. All right, when you factorize it, you'll get x minus 2, and another one will be 2x plus 1. 2x plus 1. This one is less than equal to 0. All right, now in the next step we have to find the critical points. How to find the critical points? You just need to consider x minus 2 and also 2x. All right, I'm gonna write it here. Right, you just need to consider x minus 2, 2x plus 1, which is equal to 0. Therefore we have x equal to 2, another one -1 over 2. Alright, so these are the critical values of x. Therefore we have -12 and also 2 on this number line. Now we need to consider 3 regions here, the first one, the second one, and the third one. So the first one, which is from the -infinity until -12. The second one, which is from -12 until 2. And the last one, which is from 2 until infinity. Alright, now we are going to fill out with the factor of these functions. Alright, so this is the first factor, which is x minus 2, and the second one will be 2x plus 1. And of course we need to find the product between these two factors. So we have x minus 2, we have 2x plus 1. Okay, we have to find a test value within each interval. Right, you can take any test value as long as it's easy for you to substitute. Suppose I put -1 here, and this one maybe I take 0, and this one maybe I take 3. Right, when you substitute -1 inside this and also this one, so you'll get a negative value. This one will be a negative value. Right, what about the 0? You substitute here and here, you get a negative. This one you get a positive number. When you substitute 3 inside this one and this one, you will get a positive, and this one will be a positive. When we multiply these two factors, therefore we multiply the signs here, so we have a positive number, because negative multiplied with the negative, we get a positive number. And the next one will be a negative number, and this one will be a positive number. Bear in mind that we want to have the part where it is actually less than equal to 0. This one here, right? We have to make it less than equal to 0. Therefore, all right, we want to focus the part where it is actually a negative number. So it's actually here. Right, now it's actually here. All right, so now we know that that interval is only makes the inequality negative. Therefore our final answer, so this is the final answer, will be -12 2. All right, but I don't write the bracket yet because we need to check, can we substitute with -12 and also 2? All right, because now it does not involve the fraction. All right, because and it is equal to 0. It can be equal to 0. Yes, we see here when it equal to 0, so 2 and -12 included, right? Because when you substitute with -12, and so when you substitute with 2, therefore you get 0. Therefore both values here are included. Just now we don't include positive 1, because when we substitute positive 1 here, you will get 0 at the denominator. Therefore it will become undefined. Therefore that's why we cannot take 1. But in this case we don't have the fraction, we don't have the denominator, therefore we can take both values. So this is the answer. If you want to write in the what we call the real number line, we have -12 and 2, because they are both included. Therefore we have the full circle here, right? And you connect between these two, something like this. And if you want to write the inequality form, therefore we have less than equal to 2 but greater than equal to -12. We have something like this. Okay, all right. All right, now let's see this example. Suppose we have this. All right, the equations already give you in the factorized form. So we have the factor this one. All right, sorry, you already have this factor, this one, and also this one. Therefore you just need to write the critical values, right? The critical values of x, all right, which are the first one when you consider x is -1, all right, because when you substitute -1 here you get 0. When you have the x which is equal to 2, all right, when 2 minus 2 which is equal to 0, and the last one will be x equal to 4. All right, so you have actually 4 regions here. Why? Because we have -1, we have 2, and we have 4. So the first region, which is here, which is from -infinity until -1. The second one from -1 until 2. The third one from 2 until 4, and the last one from 4 until infinity. All right, now you fill up with the factor, which is x plus 1, x minus 2, and 4 minus x. Therefore the final answer, all right, so we have x plus 1, which is x minus 2, and 4 minus x. Okay, something like this. Now you have to pick a test value. Pick any test value inside this interval, and also this one. All right, now you have, suppose I have -2 here, I want to have 0, I want to have 3, and I want to have 5. All right, you can pick any values as long as it is in the interval. Right, now when you substitute with -2, what will happen to these functions? All right, so -2 will be negative, this one will be a positive value. Right, for 0, when you substitute with 0 you get a positive, this one will get negative, this one will be a positive, sorry, this one will be a positive number. And the next one, right, 0, okay, and when you substitute with 3 we get a positive, 3 minus 2 positive, and 4 minus 3 will be a positive. When you substitute with 5, and then you have a positive number, 5 minus 2 a positive, and 4 minus 5 will be a negative number, right? So when you want to find the product and also division of these three symbols, all right, so you need to consider, right, what will happen when you combine these when you multiply and divide these symbols. Therefore you give a positive number, because negative multiply with negative will give positive, positive divide with positive number, you get a positive. This one will give you a negative, this one will give you a positive, this one will give negative. Now the question asks you, right, to consider the part where it is actually greater than or equal to 0. Therefore we need to consider the positive parts only, so it's here. So these are the intervals. All right, so our final answer, all right, so answer will be -infinity, of course not included until -1. Right, but is -1 included? So we want to have it equal to 0. It is greater than or equal to 0. So it means that it can be substituted with -1 here. When you substitute with -1 inside this, -1 plus 1 will be 0. So 0 multiply with and divide with something, so you get 0. Right, now you have -1 being included. I hope you get the idea how to get it, whether it's included or not. Right, right. Now union with, right, so from 2 to 4, right, I write 2 and 4 first. Can 2 be included? Right, you ask yourself, can 2 be included? Look at this function, right? When you substitute 2, you have 2 minus 2, which is 0, so 0 at the numerator, so also okay, so 2 can be included. But can you substitute with 4? What happens when you substitute with 4? So when you substitute with 4, therefore you will have 4 minus 4, which is 0 at the denominator, so you have an undefined functions. Therefore 4 cannot be included, because you cannot have 0 at this value. All right, so that's why 4 is not included. So our answer will look like this, right? So if you want to write in what we call the number line, real number lines, we have -1, 2 and 4. So this one will look like, all right, sorry, okay, something like this. It goes this way, and from 2 to 4, 2 included but 4 is not included, therefore you have a hole there. all right, something like this. So this is our final answer for the real number line form. But if you want to have your inequalities, it will be something like x is less than -1, all right, less than or equal to -1, union with x is between 2 is included but 4 is not included. So we have something like this, all right. So this is our answer, all right. So this is interval form, real number line form, and also inequality form. All right, let's look at the next example. Suppose we have these functions, right, but bear in mind that the numerator is not factorized yet, therefore we have to factorize it, right. So how to factorize this one? You can have like, all right, I know, I hope you know how to factorize, right? All right, so you have maybe right, -4, all right, x minus 4 and x plus 3, okay, x minus 1, which is less than 0, okay. Yes, -4x plus 3x and -x, all right, that's it. So our critical values are at 4, -3 and 1. So we have 4, -3 and 1, so -3, 1 and 4. Okay, now we have 4 parts here. So the first one, the second one, the third one, and the fourth part. And now we fill up with the interval first. So for the first one, from -infinity until -3, from -3 until 1, from 1 until 4, and the last one from 4 until infinity. And we have to fill out with the factors. So the factors are x minus 4, right? This one, let me show you, x minus 4. The second one is x plus 3, therefore we have x plus 3. And the last one, which is x minus 1, therefore we have x minus 1. And we will need to find the product and division of these factors, therefore we have x, all right, something like this, x minus 1. Now we want to have a test value. Suppose you pick any value inside each interval here, right? So you have a -4 here, maybe you have 0 here, you have 2 here, and you have 5 here. You can pick any values, right, as long as it's in the interval. So when you substitute -4 inside these three functions, what will happen? This one will give you a negative number, this one will give you a negative number, this one will give you a negative number. Now you substitute with 0, what will happen? 0 minus 4 is -4, therefore it's negative. 0 plus 3 is positive, therefore 0 minus 1 is -1. It's a negative number. Next, you substitute with 2. 2 minus 4 is a negative number, 2 plus 3 will be a positive number, 2 minus 1 will be a positive 1, therefore it's positive number. 5 minus 4 is positive 1, therefore we have 5 positive. 5 plus 3 will be 8, so it will be positive. 5 minus 1 will be 4, therefore we are positive. Now we combine these three signs, right? What will happen? So we have, right, the first one, which is a negative number, this one will be a positive number, and this one will be a negative number, this one will be a positive number. Okay, I'm doing right, no mistakes, right? Yes. Now we need to find the part where we want to focus only on the x the inequality which is less than 0. Less than 0 means it should be negative, so negative means these intervals only. So our final answer will be, right, so answer from -infinity up to -3. Why I easily consider this bracket, not this square bracket. Why? Because, okay, you see these functions here, these inequalities here, you don't have that part which is equal to 0, so you don't need to consider the border points here, all right, the border line, right? So you just easily take this one. But if it is equal to 0, you need to consider the -3 and also +4, but not what we call 1 there, right? So we have something like this. So you can have, right, suppose I have this number line, -3, 1 and 4, right? So for -3 it's going this way, and between 1 and 4, so it'll be something like this. All right, now we are done with this one, right? You can also write your answer in inequality form. All right, now we have this function. All right, so The many mistakes that students make is that they multiply. So we have something like 4 minus 3x is less than or equal to x plus 2. They multiply this to the right side. That is actually wrong. Please don't do this. Alright, this is the wrong concept. What we need to do is actually 4 minus 3x over x plus 2. We have to bring 1 to this side. Therefore we have minus 1, which is less than or equal to 0. And now we have to, you know, make it as a, what do we call, the fraction. So this one should be you should have the same denominator here. So 4 minus 3x minus 1. So you multiply x plus 2 here. So everything should be x plus 2, which is less than or equal to 0. Now simplify. So 4 minus 3x minus x minus 2 over x plus 2, which is less than or equal to 0. And then you have the, okay, you have 4 minus 2 will be 2. 2 minus 4x, right? 2 minus 4x over x plus 2, which is less than or equal to 0. You factorize the numerator, therefore you have 1 minus 2x, alright, which is x plus 2 here. Alright, now you need to consider the critical values. So what are the critical values? Suppose we have 1 minus 2x, which is equal to 0, therefore 2x equal to negative 1, therefore x equal to 1 positive 1. Alright, so x equal to half, because when you substitute half here we get 0. Alright, now the second one, which is x equal to negative 2, consider the part where the denominator will become 0. Now you have two critical values here. You just need to consider this value, which is negative 2 and also half. So we have three parts here for the interval, so which is from negative infinity until negative 2, from negative 2 until half, and from half until infinity. Alright, so we fill out with the factor. So you just need to consider this factor, right? So 1 minus 2x. Why I don't take 2? Because, right, 2 2 is a constant. It does not have the variable x. It cannot be substituted with the x. So you just need to take the part where the function has the variable x. Alright, so we have 1 minus 2x over x plus 2. Okay, something like this. Now you take a test value. Pick any test value inside this interval. You have, suppose I have negative 3, I have 0 here, and I have 1 here. When you substitute with negative 3, it will give you a positive. This one will give you negative. When you substitute with 0, you get positive number. You have positive. When you substitute with 1, you get a negative number. This one will be a positive. Therefore, we can find the product between, the division between these symbols. We get negative, positive, and negative. We want to consider the part where it is actually less than or equal to 0. So it should be at the negative sides here. Alright, now we consider this value. Now our final answer will be okay, from negative infinity until negative 2. But can negative 2 be included? What if you substitute negative 2 here? It will become 0 at the denominator, right? So it is an undefined, therefore negative 2 cannot be inside this interval. So negative 2 is not included. Union with, alright, so from half until infinity. What about half? Can half be substituted here? When you substitute half at the denominator, no problem. When you substitute half at the numerator, also no problem, because it will be equal to 0, because we have the equality signs here. Alright, so it can be equal to 0. So half can be included. So this is our final answer. Alright, so I have alright, so we have something like negative 2 and half here. So this part will go this way and half you go this way. Alright, so this is the real number line. Right, now alright, let's have this example. Alright, the common mistake that students do is actually they multiply it like this. So it'll be something like 4x is less than or equal to x minus 2. This one is wrong. Don't do it. this way, right? What you need to do is actually to bring that half to the left side. So have something like 2x over x minus 2, you minus half. So that one will be less than equal to 0. And then you have to make this as a fraction, as one fraction. So meaning to say that you have to cross multiply. Alright, something like this. Now we have something like, alright, for when you substitute with 4x minus with x minus 2 divided by 2x minus 2, right? It's less than equal to 0. Now you have the 4x minus x plus 2 divided by 2x minus 2 is less than equal to 0. 4x minus x will be a 3x plus 2, right? Divided by 2x minus 2, which is less than equal to 0. So what are the critical values here? So you just need to consider the first one, which is 3x plus 2, which is equal to 0. Therefore our x will be negative 2 over 3. This is the first critical value. The second one, which is x minus 2, which is equal to 0. You just need to consider this one. Alright, now you have x is equal to 2. So these two values are the critical values. So we have negative 2 over 3 and also positive 2. So we have three intervals, the first one, the second one, and the third one. Now we fill up the table. So we have negative infinity until negative 2 over 3, from negative 2 over 3 until 2, and the last one from 2 until infinity. And then we fill up with the factors, so which are the 3x plus 2. Alright, the second one will be x minus 2, and then when we have the final division here, which is 2x minus 2. 2 is positive, so you just don't need to consider. If you want to write in this table, also okay. Alright, also okay. Suppose I want to consider 2, alright, so okay, I want to put 2, no problem. Alright, because maybe some of you may question, why I have to ignore 2 there, sir? Alright, you'll see the answer now. Now we pick a test value, right? Any values as long as it's inside this one. So I have negative 1, I have 0 here, and I have 3. When you substitute with negative 1 inside these 3, what will happen? Alright, negative 3 plus 2 will be negative number, negative 1, negative. Alright, so what about negative 1? What if you want to substitute inside 2? Can you? No, because 2 is a constant. It does not have the variable x. Therefore, you cannot substitute with negative 1. Therefore, 2 is always positive. You cannot substitute with any values. Alright, that's the intention. So any positive number multiplied with the another number. So of course, this, this 2 does not affect that number. Alright, because it's positive. Otherwise, if it is negative, then it will affect. Alright, now when we have 0, so we have a positive number. 0 minus 2 will be negative. 3, if we have positive, 3 minus 2 will be a positive. Therefore the final answer here, alright, so these three we need to consider. So we have positive and negative, this one a positive. We want to have the part where it is actually less than equal to 0. So where is it? So it's actually the negative part. So this is the answer. But we want to write the final answer. Now our final answer, alright, so what is the final answer? From negative 2 over 3 until 2. But can negative 2 over 3 be included? Right, consider this function. Can we write negative 2 over 3? Can we substitute negative 2 over 3 inside here? Of course we can. Therefore, it is included. When it is included, we have the square bracket. Can be substituted with 2? Yes, the numerator can be substituted with 2, but the denominator, when we substitute with 2, it will become 0. So when we have a function with the 0 at the denominator, it's actually undefined. Therefore, we cannot have 2 inside this interval. So this is our final answer. If you want to write in what we call real number form, so we have something like this, right? So negative 2 over 3 included, but 2 is not. Okay, and something like this. Right, now let's go to this part. Okay, what we need to do is to bring this to this side. Do not multiply x here. Alright, the common mistake, you multiply x here, and then you have x plus 1 less than 3 minus x. That is wrong. Right, you have to bring this to this side. Right, so we have something like x plus 1 minus 3 minus x over x, which is less than 0. Now you can multiply this x here. Okay, so we'll have something like x plus 1 minus 3, all right, minus x. Be careful, because when we minus here, actually we minus the whole thing. That is the common mistake in this type of question. Okay, you divide everything with x now, because we have it as a one fraction, right? So we have something less than 0. All right, now I want to expand it. X squared plus x, right? X squared plus x minus 3 plus x, right, over x, which is less than 0. So actually you can see here that I have x squared plus 2x minus 3, which is over x less than 0. Now I want to have the numerator being factorized. Therefore we have x plus 3x minus 1 over x less than 0. Okay, all right, now we have to find the critical values. So firstly we consider this part. So the critical values is actually -3. Right now we consider this part where the critical values is actually 1, and the last one, the critical values is actually 0, because we can substitute 0 there. Right now we have the critical values, which are 1, -3, and also 0, right? 1, -3, and 0. So you consider these real number lines, so -3, 0, and 1. So you have how many regions here? 1, 2, 3, 4. So we have 4 intervals from -infinity until -3, from -3 until 0, from 0 until 1, and finally from 1 until infinity. Now we want to substitute, fill out with the factor. So x plus 3, x minus 1, and x. Therefore we have the final product here, x plus 3, x minus 1 over x. Okay, we have something like this. Now we pick any test value inside each interval. Therefore we have -4. This one can be -1. This one should be 0.5. This one should be 2. Alright, now you substitute this test value inside each function, each factor here. So what will happen when you substitute with -4? You get negative number, you give it negative number. This one, when you substitute with -1, right, inside this x, therefore we have a positive number, you get a negative number, and get a negative number. 0.5, you get a positive number. 0.5 minus 1 will be -0.5, will be a negative number. Therefore this one is the positive number, because positive 0.5, substitute at x, of course positive. Therefore you get 2, substitute at this x, you get a positive number. Substitute here, 2 minus 1 will be positive number. 2 is a positive number. You have something like this. Now we need to combine these symbols. Therefore negative will give you a negative value, right? So this one is actually a negative value. This one will give you a positive value. This one is negative. This one is positive. We need to consider the part where it is actually less than 0. So less than 0 means it's negative, so it's actually here. Oh, sorry, my mistake. Yes, this one. Okay, now our final answer will be, final answer from -infinity until -3. So because it does not include the 0, we don't have the equality there. Alright, so union with 0 until 1, very easy. Alright, -3, 0, 1, that border points are not included, therefore we have a hole here. Alright, something like this. Right, let's look at the last example here. Suppose we have these functions. So what we need to do is to always bring this to the left side. So we have this one can be combined as a fraction. So we have x plus 2 over x, right? Minus 8 over x squared, which is less than 0, right? Now we have we need to make the denominator the same. Now we need to multiply with x here. Multiply with x on both numerator and also denominator. So we have something like x square plus 2x, alright, minus 8 over x square, which is less than 0. Okay, now we need to factorize the numerator. So we factorize numerator. So we have something like x, okay, plus 4x minus 2 over x square, which is less than 0. Okay. Okay, now what are the critical values? Consider this one, x is equal to negative 4. Consider this one, x is equal to 2. Consider this one, x is equal to 0. So our critical values will be negative 4, 0 and 2. So this, put this on the number line, we have something like this. Therefore we have 4 intervals here need to be considered. So from negative infinity until negative 4, from negative 4 until 0, from 0 until 2, and finally from 2 until infinity. Therefore, alright, we fill up with the what we call the factor here. So x plus 4, x minus 2, alright, and x square. Okay, now we have the x plus 4 x minus 2 divided by x square. What will happen? Alright, now we pick any test value first. So in this case I put negative 5, I put negative 1, I put it here 1, I put here 3. Now I substitute with negative 5 first inside each factor. So I have negative number and negative number, which will be positive. Note that when we substitute any values inside x square, will be a positive number. So you just need to write it here. Now we substitute with negative 1. So negative 1 plus 4, a positive number. Negative 1 minus 2, negative. 1 plus 4, a positive number. 1 minus 2 will be a negative number. And finally we have 3. 3 plus 4, positive. 3 minus 2, a positive. Therefore we can find a final product, meaning to say that we just need to combine all these three, what do we call, signs here. Okay, so we have the first one, which is a positive, this one is negative, negative, and also the positive part. Now what do we call, our final answer will be, because we need to consider the part which is less than 0, so it's actually here. Okay, negative, right? So this one less than 0. So okay, now our answer can be, right, from negative 4 until 0. You just don't need to consider whether it's negative 4 included, because we don't have the equality sign there. We don't have. Now union with 0, 2. Why do we have something like this? Because we cannot have 0 as the point. So can we write negative 4 until 2? No, because in this interval 0 is included, but in this case 0 is not included. Alright, yes, you can write in that form, negative 4, 2, except the point 0. You can write this way. Alright, but I guess you don't understand how to write this way, right? So you better write this way, because if you write that negative 4 until 2, 0 is included. What happened when with 0 included? When you substitute with 0, this inequality will be undefined. Therefore 0 cannot be included. This is what we mean by this. So when we want to write what we call this real number line for 0 and 2, we have something like this. We have a hole at 0. Yes, it's something like this. Okay. Alright, so we are done with the nonlinear inequalities. Thank you for watching this video.